In this section, we're going to take a look at variation. There's two kinds of variation that we're going to look at, direct variation and inverse variation. Here's our first problem. We want to assume in this first problem that y varies directly as x. And then we say this: if y is 39 when x is 3, find y when x is 10. So our first sentence tells us that y varies directly with x, means that y is equal to some constant k times x. Next, we use the first phrase of this sentence: if y is 39 when x is 3, that will tell us how to find k. So I'll substitute 39 for y and 3 for x. And so I have 39 is equal to k times 3. Dividing both sides by 3, I end up with k is equal to 13, because 39 divided by 3 is 13. Now that I know that k is 13, I'll put that back into this equation and rewrite it specifically as y is equal to exactly 13 times x. Now I'm ready to answer my question here, or to find y when x is 10. I'll just substitute 10 for x, and I end up with y is equal to 130. So if y varies directly as x, and y is 39 when x is 3, then when x is 10, y is going to have to be 130. So this is how we solve a simple direct variation problem. Let's look at our next problem, an inverse variation problem. We want to assume that y varies inversely as the square of x. If y is 4 when x is 3, we want to find y when x is equal to 2. So first of all, I'll take my first sentence right here. It says y varies inversely as the square of x. So that means that y is equal to k divided by the square of x. That's inverse variation. Then I know that y is 4 when x is 3. So I'll substitute in and get y is equal to 4 when x is equal to 3. So k divided by 9 is equal to 4. I'll multiply both sides by 9. So those 9's divide out, and I end up with k is equal to 36. So k is equal to 36. I'll put that 36 back into my original equation, and I end up with y is equal to, specifically, 36 divided by x squared. Now I'll go over to the original problem, and it says to find y when x is equal to 2. So I'll take 2 and substitute it for x in this equation, and I end up with y is equal to 36 divided by 2 squared. 36 divided by 4 is going to be equal to 9. I hope that comes out on your screen. Looks about, it might be a little tight right there, but in any case, I have y is equal to 9 if y varies inversely with the square of x. Y is 4 when x is 3, then when x is 2, y has to be 9. Let's look at one last problem. Okay, in this problem, the power P in an electric circuit varies directly with the square of the current I. If P is 30 when I is 2, find P when I is 7. Same type of problem. Let's see. The power P varies directly with the square of the current I, so I use that to write that P is equal to K times I squared. Next, P is 30 when I is 2, so I'll substitute in and get 30 is equal to K times 2 squared. So that's 30 is equal to 4K. Divide both sides by 4. K is equal to 30 divided by 4, which comes out, I believe, 7.5 if I do that division. K is equal to 7.5. Okay, I'll substitute that back into my original equation, so I'll get specifically that P is equal to 7.5 times I squared. Then I want to know what is P when I is equal to 7. So I'll substitute 7 for I, that's going to be squared. So 7.5 times 49. And let's see, I've worked that out, and that comes out to be 367.5. So 367.5. So if the power P varies directly with the square of the current I, and P is 30 when I is 2, then when I is equal to 7, P must be equal to 367.5, and that's how we solve variation problems.